Okay, so today what we're going to do is continue our lesson in algebra, our lessons in algebra, exploring some of the algebra skills that you're going to need. And one of the things that is really important that you understand is how to work with fractions. And I know that you've had lots of lessons in fractions in your career, ladies, in your career, but we are now going to be talking about introducing algebraic fractions. Now, what's the difference, do you think? What makes it algebraic?
That the line means divided by.
Well, that's what makes it a fraction, but what makes it algebraic?
The variables.
There are variables in them. There you go. So anytime you have a variable in it, you know that it's an algebraic fraction. Now, the beauty here is that... Here we go. So, the good news is that the rules for fractions never change. Nothing ever changes just because you've introduced the variables. The way they look changes, though, and they may look much, much worse than they did before, but they really don't. So first, let's talk about, or just review, the idea of multiplying fractions. Now, again, I don't know your background. I don't know where you've come from, but I'm going to show you the way that I think is the most efficient. And I'm not going to insist on it. If you get the answer doing it a different way, that's fine. But I'm going to warn you that if you don't follow the rules that I'm about to set out, then it's going to get very complicated later. Right? Did I say it wouldn't work? Nope. I just said it's going to get very complicated later. So, the first and most basic rule of all fractions is that you should simplify. Now, this is also known as reduce. Do you know those words? Or do y'all have another word for it? So say, for example, you have 8 over 4. Both of those will divide by, well, let's not use that fraction. That one will divide evenly. Let's use, 2 over 6. How's that? Right. Simplify is that math word that says do everything you can.
Okay.
Do the math. Yeah, simplify means do the math. So simplifying or reducing means looking at your fraction and seeing, is there any number? Because first of all, you want to see, can I divide a 2 by a 6? Please say no, right? If it was the other way around, could I divide a 6 by a 2?
Yeah.
Yes, but you can't divide a 2 by a 6. But what number will they both divide by? 2. And so if you divide the numerator by 2 and the denominator by 2, you reduce it to 1/3. Remember that? So that's simplifying a fraction or reducing a fraction. Did you all have a different term for that? Instead of reduce or simplify, what do you all call that? Pardon? Okay, well, canceling would mean that they just eliminate, right? You're canceling like terms, maybe? Is that what y'all call it? I'm sorry. Reduce. Okay, so reduce is a word that you use. Sorry, I'm trying to learn New Zealand math language. So perfect. Okay. Now, you may have been taught that you don't need to simplify or reduce first before you multiply, and you don't technically. But because these fractions are becoming more and more complex, if you don't simplify first or reduce first, then you're going to get into trouble later. They'll simply become so complicated that you'll make a giant mess that you can't dig your way out of. Okay? But when you're simplifying, when you're talking about just one fraction, that's pretty easy because you only have 2 numbers to look at, right? But if I'm multiplying, that means I'm going to have at least 4, right? I'm going to have a numerator and denominator from the first fraction and a numerator and denominator from the second fraction, right? And I could possibly have 3 or 4 fractions multiplied together. So when you're simplifying, what you have to remember is that because it's all multiplication, remember multiplication is that one operation that just lets you do pretty much anything you want to, right? You can simplify any numerator to any denominator. Remember what the numerator means? Which number is that? The top number, and the denominator is the bottom one? Yes? Excellent. Good. And so it doesn't matter which fraction it comes from, any numerator to any denominator can simplify. So for example, let's say we have our 2 and our 6 times 4 over 12. Who cares? Okay. What operation is, the very first thing you should always do is identify the operation. If you don't know what operation you're dealing with, then you're never going to be able to work these. What operation is indicated here? Multiplication. And you also need to know what you're multiplying with. These things are not just numbers. These are what? Fractions, exactly. So you need to go to the rule for multiplying fractions. And again, that's the hardest part of mathematics. What am I being told to do, and what am I doing it with? Right? So, I'm multiplying fractions. Well, let's go to our rules. It says that before I multiply fractions, the first thing I need to do is what? Simplify or reduce. And that can be any number, any fraction. Actually, I'm going to change these numbers a little bit because I want to show you something a little. Let's put a 3 there and a 9 there. Okay. Now, doesn't matter. First of all, we'll see, can I reduce up and down in the fraction? So let's look at this first fraction of 2/3. Right? Is there anything that will divide into both 2 and 3 at the same time other than 1? No. 1 divides into everything, but that doesn't ever do you any good, right? Okay. Now, go to the second fraction. Is there anything that will divide evenly into 9 and 12 at the same time? Yes.
3.
They'll both divide by 3, exactly. So, what we can do is we can divide the 9 by 3, which will give us 3. 12 divided by 3 will give us a 4. And 3 and 4 don't have anything else that will divide into them, right? But remember, we're multiplying fractions, which means I have more than one fraction to think about, right? So I can simplify any numerator to any denominator. So looking at this numerator of a 2, now I know I can't simplify it with the 3, but don't 2 and 4? Because it's multiplication, I can. So, what do 2 and 4 have in common? 2. So when I divide the 2 by itself, what do I get? 1. Oh, be careful. 1. And 4 divided by 2 leaves me what? 2. Now, look at here. Here's a 3, and there's a 3. What will they both divide by?
3.
Absolutely. They'll both divide by 3, so that gives you a 1 there and a 1 there. And now I've simplified everything that I possibly can. Now, be careful. I wrote everything on without rewriting it all, but I was very, very neat. And you can do that. But some of you aren't neat. I've seen your papers. All right? So if you promise to be very, very neat, you can do one thing in a clump, right? But if not, then you need to be rewriting things as you go. So, for example, you might have seen, 2/3 would not change. 9 over 12 became 3 over 4. Then I'll do this one. Then I'll do that one. Do you see what I'm saying? So, oops, thank you. I'm going to fix that. So you need to make sure that you take as much paper, as much room as you need to be able to get the right answer. I'll always have paper up here. Usually. And so you feel free to use as much as you want to. Okay? But because remember that it's not about saving a tree. We'll plant a tree together as a class. But, sure. Well, we'll find somebody to donate and plant a tree or something. But make sure you do enough to make sure you understand what's happening. Yes?
The way you can remember it is that the multiplication sign is an X and you can write it like that.
Exactly. So you can reduce across. Now, let's talk about the second step. Now that I have it all simplified, the second thing I need to do is simply multiply straight across.
Yes. Sorry.
Okay? So it's numerator times numerator and denominator times denominator. So whatever's left after you simplify will be what you multiply. So here's what I have left, right? Oops, sorry. That's not what I have left. Here's what I have left. Let me go ahead and just rewrite it because it's looking really bad. I have 1 over 1 times 1 over 2. That's all this stuff simplified, right? And again, remember, that's one reason why it pays to rewrite it, to make it as neatly as you can. So then I'm just going to multiply how? Straight across. So in the top, I have 1 times 1, which is what? 1. In the bottom, I have 1 times 2, which is what? 2. And you're done, right? So it's not a complicated process. Now, I know I drug it out a bit because I wanted to explain exactly what's happening in every piece of it. You know some of it, that's good, but it's not good enough. You got to know how much of it. All of it. And how much of the time? All of the time, right? So you've got to make sure that you're studying these rules and the processes. Okay? Now, the only difference here is that we didn't have algebra here because there's no variables, right? So, but what we do need to do is we need to look at some that do have variables in them. So let's go to our Education Perfect and see what they have for us. Okay? All right. You can always tell when it's the teacher. They always define the teacher as a sloth for some reason. I guess because we're lazy.
Because you make us do all the work.
Right? And my hair doesn't look like that. Matter of fact, I don't have that much hair. Oh, well.
Einstein's hair.
There we go. Einstein, he's a genius. So, welcome to the lesson on multiplying algebraic fractions. Why do they call these algebraic fractions? Sure. Because they have variables in them, right? That's the only difference between arithmetic and algebra, isn't it? Excellent. So let's say we have 3/4 of a pizza and we want to eat 2/3 of it. Whenever you see the word of always means to multiply. Okay? So that's one of those key words that you'll see quite a lot in story problems or word problems is the word of. If you're dealing with of, everybody wants to divide for some reason, but it's not.
That sounds correct.
Of means what? Multiply. So if I take 2/3 of a number, that means 2/3 times that number. Okay? Again, just got to learn it. Okay, so every time you see the word of, it means multiply. Okay? So we could express this sentence using fractions, right? We had 3/4 of a pizza, so that's 3/4, right? And we want to eat 2/3 of it. So that means 2/3 of the 3/4 that we had. So 2/3 times 3/4. Does it make sense?
Because afterwards we'll get a smaller number and we can just relate multiplying and getting bigger.
Well, but when you multiply with fractions, does it get bigger? No, because when you multiply with fractions, what does that fraction bar mean? To divide. So you're multiplying with division. So that's what's different. It's okay. You'll survive. So to calculate this, we're going to multiply the tops together. Okay, so here is what I absolutely do not want you to do. This is what you learn when you first learn fractions and you don't know any better. Well, that's not y'all, right? Y'all are learning algebra. So you're beyond that. So are we all in elementary school now? Primary school? Yeah. Oh, are you? It's middle. So that means you're in the middle, so you better fix it, okay? So this is an example of what I'm talking about that I do not want you to do. Do you see what they did was they just multiplied straight across and then got a fraction here, and then they're going to simplify it or reduce it. Now, exactly, because in algebra, you're going to have fractions that look like this. Do you want to, and then multiply that times something else hold on. Do you want to multiply that times something else just as horrible?
Yeah.
No. You want to reduce that before you begin. Okay? So, be careful. Always simplify first. And I don't care what anybody else tells you. Simplify first because you think about it. You got to know where you're going with things, right? That's what makes it easier. If you know where you're going, then it makes it easier to get there, doesn't it? So simplify first. So let's do this one. Let's just go back to the previous page, and we'll do this one our way. Okay? So what we have is we have 2/3 times 3/4, right? Before I do the multiply, I need to simplify. Good. So notice, is there anything to divide evenly into 2 and 3? No. Is there anything to divide into 3 and 4? No. But remember, because it's multiplication, I can not only simplify up and down, but what?
Side to side.
Well, diagonally, right? Okay? Any numerator to any what? Denominator. Okay? So, is there anything that'll simplify here and here?
Yeah.
They'll both divide by?
2.
2, right? So that 2 is going to turn into a 1, and this 4 is going to turn into a what? 2. Excellent. Those don't exist anymore, so mark them off neatly. Don't get too carried away when you're marking stuff off, though, because you might make a mistake and you don't know where you made the mistake. So be careful. Now we'll look at the other numerator. Here's a 3 up there. Is there a 3 anywhere down in the bottom?
Yes.
Yes. So they'll both divide by 3, which will turn them both into what?
1.
Ones. Now that I've got it all reduced, I can multiply how? Straight across. So 1 times 1 is 1. 1 times 2 is 2. And it ended up being 1/2, just like the other example we did.
Exactly
That's
what happens
right.
in our exam.
So therefore, we can conclude that all fractions end up multiplying to be 1/2, right?
What?
No, just kidding. Yeah. It is ironic. It is ironic, though, that it did come out to be the same. So be careful. As they get bigger, it's going to be more trouble if you don't reduce first.
How did you reduce the...
Okay? Let's see. So how did I reduce? Remember, they wouldn't reduce up and down. 2 and 3 won't have anything to reduce, right? 3 and 4 won't either. But we can reduce any numerator to any denominator. So it doesn't matter which fraction it comes from. As long as this is multiplication, I can reduce diagonally here or diagonally there. So there's nothing that'll divide by 2 in the bottom there, but there is something there, right? So they'll both divide by 2, and that's where I was getting those numbers. And many times it's easier if you just go ahead and don't look at it up and down. So like, here's a 2. Is there anything anywhere down here that'll divide by 2? Yeah, the 4, right? So you can even just start by looking at either of the numerators. Okay, good question. All right. Now, and then they're just going through, showing you pictures of what's happening. So now, let's look at multiplying fractions with variables, because this is our goal here. So look at the one that they have. So we have 2p over 7 times 4p over 9. Now I want you to be careful here. First, before we do the multiply, we're going to simplify. I like to use the word simplify because it rhymes. It's multiply, simplify. But you can use reduce. I don't care. Any numerator to any what? Denominator. So our first numerator is what? 2p. Well, what that really means is 2 times p. Right?
Yeah.
So I can use them separately. I can look at the 2. Remember, you divide the coefficients first, and then you divide the variables, the bases. So the first thing I have up here is a factor. Remember, we've said that word before. Factor simply means anything that's multiplied together, right? You're dividing away common factors, right? That's what you're doing here. So here's a 2 in the top. Will 2 divide by 7? Will 2 and 7 have anything in common? No. Well, I can look at the other denominator right now too. Is there anything common to 2 and 9? No. So there's nothing that's going to happen to the 2. It's not going to change, right? Well, what's the next factor in my numerator? P. Is there a P anywhere in the denominator?
No.
So that can't divide away. Not in the denominator, right? Okay, right, be careful. So here's a 4. Will 7 or 9, do they have anything in common with 4? Nope. So that won't reduce. Here's another p. Well, if there wasn't anything down there before, then there's not going to be now, right? We didn't change the numbers. Now, but there is a 2 and a p and a 4 and a p. Can I divide? Can I reduce straight across?
No.
Well, only how? Diagonally. In other words, I have to be crossing that fraction bar in order to reduce. Now, if it was like this, could I reduce them?
Yes.
Absolutely. Because reducing means divide, and so that means you have to be using the division symbol. Okay? So, could I reduce anything? Nope. So that just means I have to multiply everything how? Straight across. So let's start multiplying. 2 times 4 gives me?
6.
Be careful, multiply, 8. And then I have a p times another p. Remember yesterday we learned how to do that. So what do we do when we're multiplying with variables? You keep the base and do what to the variable?
You add a power.
Add the powers. Good. So remember, it's p times p, which is p to the first and p to the first, so p to the what? Second. Remember that? Some of you might not have done that exercise yet. And in the bottom, we have 7 times 9, which is... Come on, guys. 63. There you go. Now, and that is your completed answer. And the beauty of it is, right, if it didn't reduce here, then it's never going to reduce there. Right? After you've multiplied it out. It won't reduce anymore. Okay? Because if you thought about it, 8, you could see 8 divided by 63 is not going to work. There's no p's in the bottom, right? But think about it. Is it easier to reduce with these 2's and 4's and p's? Yes. Or is it easier to reduce with 8's and 63's and p squareds?
2's.
Right? So reduce first while the numbers are small. Don't multiply everything out and get huge numbers and then try to figure out what goes into it. Yeah? So always reduce first. Okay. All right, so you get to see there, 8p squared over 63. Okay. All right, here we go. Let's do this one together because some of you might not have practiced your division yet. So here we go. What operation is indicated here? Sure. Multiplication with what kinds of numbers? What are those things? Fractions, right? And you have to know because it's not the same as multiplying a 2 times a 3, is it? Okay? So, multiplying fractions. So, for multiplying fractions, the first thing is, before I do any multiplying, I need to what? Simplify or reduce. Good. And I can simplify any numerator to what? Any denominator. So, let's look at, the first thing I have up here is an 8. 8 and 9 don't have anything in common, right? But what about 8 and 10?
Yes.
They'll both divide by what? 2, right? So 8 divided by 2 gives me what? 4. 10 divided by 2 gives me what? 5. Now, I didn't have to look at that denominator first, but I like to just go in order. Keep things neat and organized. What's the next factor of the numerator? A squared. Is there an A anywhere down here in the bottom? No, so it's not going to change, right? And I'm going to rewrite it because I'm getting messy here. What's the next factor? B. Is there a B anywhere in the bottom? No, so can't do anything there. Okay. Now, we'll go to the next term, which is 5. And is there a 5 anywhere in the bottom? Yes, right under it, right? So 5 and 5 will both divide by what? Sure. They'll both divide by 5, and they'll make 1s, right? Sorry, I set you up for that one. I did it on purpose. So those 5s turn into 1s. The next factor is A. Is there an A anywhere in the bottom? Nope, so it won't change. Then we have a B. Is there a B anywhere in the bottom? Nope, so it won't change. Notice how I'm rewriting the entire thing at the top just to keep it neat and organized. Okay? Yes?
You forgot to write the B on the...
Oh, I did do that. Thank you very much. Okay. Now, explains why I always get things wrong. Now, what do I need to do now that I've simplified it? Multiply how?
Across.
Straight across. So first, we'll start with 4 times 1, which is what? 4. Then we have a to the second times a, which is what?
A to the power of 3.
A to the power of 3, or a to the third. Excellent. Good job, guys.
Did you say A to the third?
A to the third is perfectly fine. Yeah. And B times B is?
A to the second.
Oh, B to the second. There you go. It's all right. You got the math right, just the wrong letter. And now in the bottom, multiply straight across. What's 9 times 1?
9.
And there's your answer. Piece by piece.
I'm sorry, that was so tired.
It's all right. It happens. How does it look? Think you can do that?
Yes.
Excellent. I'm so pleased to know it. Now, so you can see
They
that.
need to do it a lot longer, like way up.
Oh, yeah. Way longer. Do you see what they did? Look at what they did. They multiplied the top and got 40A to the third, B to the second. So they got that as their top and they got that as their bottom. Then they reduced it all out.
That's powerful.
Do you like working with really big numbers or working with a 2?
2.
Thank you. So do it my way first and then you won't have to. Because I'm always right. Except when I'm not. Okay. So there you go. So you see their final answer. Right? Good. Okay. So that's the end of that lesson. Let's see what else they're going to do to us. Canceling. How much do I love the word cancel? Not at all. Okay. So it means reduce. What does it mean? If you divide something by itself, it doesn't cancel. It makes a 1. Excellent. Okay. So what we're going to do now is we're going to look at what happens when you have variables on the bottom. Do you think it's going to change the process at all? No. We wrote the rule. The rule is the rule, and it doesn't matter. It's never going to change. Okay? So let's look at this particular fraction. Ignore what they've written because you know we're not going to do it the way they did. So we have 2a over 3a times 3b over 4b. Again, what operation is indicated by that dot?
Times.
You bet. Multiplication. So, and I'm multiplying with what kinds of numbers? What are these things? Fractions. Excellent. So if I'm multiplying fractions, that means before I multiply, I need to simplify, which means divide out any common factors, numerator to what? Denominator. Does it matter which one? No. So let's just start with the first factor. What is the first factor? And remember, I'm calling them factors because it means 2 times a. Factors are anything that are multiplied together. Okay? Now, there's not a 2 or anything divides by 2 in the bottom there, but how about over there? Yes. 2 and 4 will divide by what? 2. 2 divided by itself gives us what? 4 divided by 2 gives us what? 2. Excellent. The next factor up here is an A.
And then A in the bottom.
And there's an A right below it. A divided by A makes what? 1. But do I need to write the 1? No, because, well, be careful. No, there are already numbers there, so I don't need to write the 1s, right? Do you see that there's already a number there? If there's no other number there, then you need the 1, but otherwise you don't. Now, yeah, let's go to the next factor. So here we have a 3. There's no 3 in the bottom here, but what do you notice over here? And 3 divided by 3 will make what? 1. Now, I need the 1 here because I don't have anything else over there, do I? I have the B, but I'm not through working with it yet. And I need the 1 here because all of that is gone, right? Okay. If everything else is gone, then you need it. What's the next factor up here? B. Is there a B in the bottom? Yes. No, because remember, we already divided away those A's. They don't exist anymore.
I know, but when we did, there wasn't anything in the...
Yeah, there was still the 3 at that time. Remember, we just eliminated the 3, so there was still a 3 at that point. Yeah, good question though. What about B divided by B? What's it make?
1.
Do I need to write the 1?
No.
No. So that's where the idea of cancel comes from. And now that I've gotten rid of everything that I can, I just multiply how? Straight across. My whistle is never going to make a difference to you, is it? 1 times 1 is going to make what? 1. 1 times 2 is going to make what?
2.
It's the same one again.
So all fractions lead to 1/2, right? No. Okay.
Shall we get one
Okay.
that isn't a half this time?
Yeah.
All right. And remember, anything divided by itself makes a what? 1. Excellent. But you don't even need to write the ones. All right, here we go. So I have a to the 7 divided by a to the 4th. That's just a division problem, isn't it?
Yes.
Okay, divide it. So that becomes a to the 7 what? Minus 4, which is a to the power of 3. I know.
That's so confusing.
Wait, can you explain that, please?
Remember that when you're dividing powers with like bases, you keep the base, and what do you do to the exponents? Subtract them. That was yesterday's lesson. Did y'all do that lesson? Okay. Remember, you've got to practice before you come back because we're going to use everything that we've learned before. Right? Good job. And so that was just division. And don't worry about their blotting of it. All right, here we go. Go.
What?
Yay.
Oh,
yay. Get to that one.
10, 8.
I don't want to do the bigger ones. Y'all do those. Yeah. Yeah.